All right, so we're going to keep multiplying fractions. Today we're going to add mixed numbers.
Is this one?
It doesn't matter. So we're going to change mixed numbers to improper fractions before you multiply. So this way we'll just reduce it down so there's just a top and a bottom, just a numerator and denominator, and we won't have that whole number sitting out in front. All right? So everybody should have their notebooks open and your pencils ready. We're taking notes. All right, so on this first problem, this fraction 3/4 is okay. The 1 2/3 we need to change to an improper fraction. So raise your hand if you can tell me how to do that. Brian.
In that side,
Yep.
you multiply by 4. In the other side, you multiply 3.
Okay. Interesting. Sam.
You just add 3 to the 2 on the top.
Okay, technically, we're taking 1 times 3 first, which is 3, and then adding the 2. Since it was a 1, that works out. So 3 times 1 is 3, plus 2 is 5. So this changes to 5/3, and then times 3/4. Now remember, with multiplying fractions, you do not do common denominators. Who really wants to do that anyway? It would just make the numbers bigger to multiply. So I'm going to use method 2. I'm going to look at this and see if there's anything I can cross-cancel. So 5 is not going to reduce with anything on the bottom. But look, I have a 3 on the top and on the bottom. So 3 divided by 3 is 1. 3 divided by 3 is 1. And that takes care of it before I multiply. So I just have 5 times 1, which is 5, and 1 times 4, which is 4. Now when we get to the end, we usually want to change this back to a mixed number. So I've got 5/4. Some of us are still struggling with this, so I'm going to write that out to the side. We've got lots of room. So I'm going to set this up as a division problem. This is 5 divided by 4. So 5 goes in the little division box, and 4 goes on the outside. And this is not a super hard long division problem. It just helps us figure out what the whole number is and what the fraction is. So 4 goes into 5 one time. 1 times 4 is 4. Subtract, and we get 1. This remainder tells us how many fourths are left. So I have 1 whole, and then I have 1/4. So this number becomes the numerator. What you're dividing by becomes the denominator, which we were dealing with fourths. It makes sense that this is fourths. So my final answer is the 1 1/4. Okay? So we'll practice that as we go through too. These are skills, things that you guys know how to do. We just haven't practiced it enough throughout the year. Just reviewing a lot of little details. So on the second one, I have 5 here. I have 3 1/2 here. Who can tell me how to change 3 1/2 into an improper fraction? Jaden.
2 times 3.
Okay, so 2 times 3
equals 7.
plus 1 is 7. So 2 times 3 is 6, plus 1 is 7. So that's going to be 7 halves, and you just keep the denominator. And then how do I make 5 into a fraction? Tommy. Put it over 1. So I'm just going to make that 5/1. Now everything in the problem is a fraction. When I look at this, there's nothing that 5 can cancel with down here. There's also nothing that 7 can cancel. So if nothing cancels, we just go back to the old-fashioned multiply across the top, multiply across the bottom. So 5 times 7 is 35. 1 times 2 is 2. Now we want to change this back to a mixed number. So over here I'm going to set up some long division. I've got 35 divided by 2. So 2 will go into, yes, TJ. Yep. So 2 goes into 3 how many times? Once. Good. 1 times 2 is 2. We subtract. We get 1. Bring down the 5. How many times does 2 go into 15? Go ahead, Tommy. 7. So I have 7 times 2 is 14. And this remainder tells us how many halves are left over. So 35 halves is the same thing as 17 1/2. So this number goes up here, and then we were dealing with halves all the way through. That's what we're dividing by. That's where the bottom number comes from. So you can set it up like long division to change this to this. There are other methods, but it's mostly just long division. Sometimes people do it in their heads. It's the same thing. Okay? So let's look at the next one. So our same process to change 3 1/4 into an improper fraction. So 4 times 3 is 12, plus 1 would be 13. So we have 13, and then we just keep the fourths, and then times 4/5. Now if I wanted to, I could just multiply across 13 times 4 and 4 times 5. That's going to give me a pretty big number on the top though. What could I do instead? I could go ahead and reduce. What can I reduce?
4 and 4.
The 4 and the 4 I could cancel. And so then I'm going to have just 1 and 1. Just divided both of those by 4. So 13 times 1 is 13. 1 times 5 is 5. And I get 13/5. And then we'll just change that back into a mixed number. So I'll put 13 in the little division box and put 5 on the outside. And 5 doesn't go into 1, but it'll go into 13. How many times does 5 go into 13? Twice. 2 times. Good job, guys. So 2 times 5 is 10. We subtract, we get 3. And then raise your hand if you can tell me what the fraction's going to be. Go ahead. 3/5. So 2 and 3/5. So 13/5 is the same thing as 2 and 3/5. Okay? So what's going to change as we get down to the bottom half is now I'm going to have 2 mixed numbers to change to improper fractions. It just adds a little bit of extra switching around, but we have to have them as just as fractions with just a top and a bottom so that we can attack these. So we're going to take 3 times 3, which is 9. We're going to add 1, which makes 10. We get 10/3. 2 times 4 is 8, plus 1 is 9. And we have 9/2. Now I could multiply these across. I'd get 90 over 6, but then I'm going to do a lot of reducing, a lot of simplifying. Can we cross cancel anything?
Yes.
Yes. What can we cross cancel?
2 goes into 10 and...
Okay, so 2 goes into 10. So if I divide 10 by 2, I get 5. 2 divided by 2 is 1. And then the 9 and the 3 will also work. I'm taking 9 divided by 3 to get 3. 3 divided by 3 gives me 1. And so then when I multiply, I'm going to have 5 times 3 on the top, which is 15, and just 1 times 1 on the bottom, which is 1. And then 15 over 1 I can just write as the whole number 15. So if you're cross-canceling up here, that helps. And if it's confusing you to think about reducing across this way, you could do what I was showing you yesterday with switching the numerators. So we had 10/3 and 9/2. 10 times 9 and 9 times 10 would be the same thing. If you wanted to, you could switch these numerators and make it 9/3 and 10/2 and reduce them so that they look like fractions that are together. If that makes you feel better, because then this would just be 3 and 5, and 3 times 5 is 15. That's really what we're doing with the cross-canceling, is we're just kind of imagining that we're switching those numbers around and simplifying the fractions. I just don't always want to rewrite it. And so that's another thing, if it makes it easier for you to understand, do that. Switch the numerators around and then simplify individual fractions before you multiply. It'll still make the numbers smaller for you. Okay, so let's go down to this one. So 2 and 1/4, I'm going to take 4 times 2, which is 8, plus 1 would be 9, so we'll have 9/4. 2 times 6 is 12, plus 1 is 13, so we're going to have 13/6. Okay, I want some new volunteers. I've had Jaden and Tommy doing a whole lot. Somebody else help me. Can I cross-cancel anything? No, you already have answered a lot. We're making other people wake up and answer. Other people need to wake up and answer. So what can I cross-cancel on this one? Raise your hand. Yeah, you guys, somebody else needs to answer.
She's going to start calling names.
Yeah, I'm going to start calling them. Okay, so Sam, I'll let you do one more.
The 9 and the 6.
Okay, so the 9 and the 6. What can I divide them by?
2 or 3.
3. So 9 divided by 3 would make this 3. 6 divided by 3 is 2. So now I have 3 times 13. That still seems kind of big, but it's not as big as it would have been. 13 times 3 is 39. So that means I'm going to have 39 on the top, and 4 times 2 is 8 on the bottom. All right, so how do I change it into a mixed number? Are you guys... Divide. So, Bennett, tell me how to set up the long division. Which number goes inside the box? 39. 8 goes out here. So 8 doesn't go into 3, but will go into 39. How many times? Somebody knew. Somebody knew.
Why?
I'm going to start calling on names, which I hate to do because it embarrasses people. Come on. How many times does 8 go into 39?
It's so easy.
Shh. We're recording. Don't make lots of noises. Rylan.
It goes in 4 times.
4 times. So 4 times 8 is how much?
32.
32. Good job. So now if I subtract that, 9 minus 2 is 7. And remember we were dealing with 8s. 8's what we're dividing by, so my remainder is going to be 7 over 8. So that's my final answer for that problem. All right, we're going to do one more together, and then the last one you guys are going to do on your own. So make sure you're awake, you understand what's going on. If you don't understand what's going on, you need to ask questions. Okay, so 2 times 4 is 8, plus 3 would be 11, so 11 fourths. 8 times 1 is 8, plus 1 is 9, so I have 9 eighths. Is anything there going to cross cancel? Got 11 and 8, and I've got 9 and 4. No, so we're going to have to do this one the other way. 11 times 9 is 99. 4 times 8 is 32. Now these are big numbers, but don't let that freak you out because you know how to do long division with numbers that have multiple digits. It's okay. We're going to take 99 divided by 32. Now in my brain, I'm thinking if this were 33, this would be a really easy problem. It'd be 3 times. This is just a little bit smaller. So, well, it's still 3 times. And then off to the side, I could do 32 times 3, which is going to give me 96. And so I'm going to subtract 96. You just need to go away. Like, we're lessoning right now. 9 minus 6 is 3. And so then what's my fraction going to be up here? Raise your hand if you know. I need some... Rhett, tell me.
332.
3/32. I know, so doing those fraction names is hard. So 3/32, 3 over 32 is correct. All right, so this problem down here is going to be a practice problem. And after we have checked your answer, then you may work on the back side of your worksheet, and we're also going to pass back some papers and do some things. So, okay, I need to find my thing from, I need to show